Welcome in today's lesson in mathematics. And today in our class, we are going to continue with algebra, number and algebra. Basically, today we shall look at dividing decimals. Dividing decimals. Now, earlier on, as you have always seen, we said a decimal is part of a whole, where a whole means one. So a decimal is simply part of one, not complete one, but part of a whole. Now, just like we've always had in multiplication of decimals, today I want us to look at division of decimals. Now, I want us to consider this. Consider 24 divided by 4. In ordinary case, these are both all numbers, and when they are all numbers, you simply divide and you get the answer as 6. If you don't want to use it this way, you'll say, if you don't want to write it like that, you'll write as 24 divided by 4. You get the answer as 6. Similarly, you can also say 24 divided by 4, and you'll find the answer as 6. So what are we trying to say here? I want you to notice the following, that when you are dividing numbers here, the number 24, in this case here, 24 is what we call the dividend. This is the dividend. When what we have as 4 down there is what we call the divisor. Then we have the answer we are getting, which we are calling 6. We call it the quotient. So, when you are dividing a number, there are 3 basic terms we come across. The number that you are using to divide, which you call the dividend. We have the one which is dividing a number, we call the divisor. And we have the answer that we get, in this case 6, which you are calling the quotient. So we can simply agree and say, this one here is what you're calling the dividend. This one here is the divisor. And this one here is the quotient. So in our lesson, we are going to apply these particular terms most of the time as we go on with the division. So let us now look at this decimal and see what happens when you are dividing. Let us just consider a few situations. Let us consider a situation, for example, of 10 divided by 0.2. Let us also look at a situation where we have a number like you can still use 10 divided by 0.5. Before we look at this, you need to estimate. What do you think you may get? Do you think you'll get the quotient that is greater than 10 or less than 10 for both the two cases? You'll notice that in both two cases, you'll always find that when you multiply a whole number by a number that is less than 1, the answer should be always less than the dividend itself. So we expect the answer here to be less than 10. We expect the answer for the second question also to be less than 10. Now, how do we approach this? I want us to look at the steps that are very vital, very important when we are approaching questions or handling questions on dividing decimals. There are steps that need to be followed. Now, first, division of decimal numbers and whole numbers. Division of decimals and whole numbers. If you are handling this, first, we must know that we should be able to divide decimals by whole numbers by simply, we need to have our division just completely as we always do while handling the ordinary whole numbers. So when dividing decimals and whole numbers, we handle it just like the other division of whole numbers. Now, but the decimal point of the quotient is just coming to be exactly above the decimal position of the dividend. You're saying that you are dividing a decimal, for example, let's take 60.524 divided by 4. Now here, if we are to handle this, we find that it is 60 divided by 4. So this particular case here, 60 by 4 is 1, carry 2. 20 by 4 gives us 5. What we are saying now here is that the decimal point comes directly above. This is the dividend, this is the quotient. On the same position but above. And then we move on with the division in ordinary way. 5 by 4 is 1, carry 1. We have 12 by 4 gives us 3, and 4 by 4 gives us 1. So what we are saying is that the division is taking place just like an ordinary, the normal numbers division, but the decimal position is of the quotient and of the dividend are in the same line. That's what we normally consider. The other point to have in mind when dividing decimals and other decimals numbers, first we need to change the divisor into a whole number. We change the divisor into a whole number. And the change here, we expect that the change you will make on the divisor should be the same change you're going to make in the dividend. For example, if you have to multiply the divisor by 100 so that you eliminate the decimal and make it a whole number, then also the dividend you have to multiply by 100. Let us look at an example here. We have two numbers here, 24.562 divided by 0.02. Both the two cases are all decimals. But now here we are saying that for us to be able to divide this, we must reduce the divisor to be a whole number. You realize that the decimal places are 2. We need to move to the right 2 places, which means like we are multiplying by 100. If we are to do that, then as we move 2 places for the divisor, we also move 2 places for the dividend. So as this one moves, so that we remain with 2, this one will also move. But put in mind that we had some assumption of certain zeros or certain multiple of 10 multiplied by 2. In this case, you realize that 100 multiplied by 0.2 is 2. So we are putting in mind that what we have multiplied by this to eliminate this decimal is 100, which is a multiple of 10. So you'll find that the new figure we have is 2456.2 divided by 2. Reaching there, the division becomes normal, usual. You divide the way you could divide any other number. So for this particular case, we have 2456.2. We are dividing by 2. So this one will give us 1. This one gives us 2. 2 carry 1, 16 gives us 8. And then we have 1. So we have 1,228.1. But then, is that going to be our answer? I say no. Why? Because there was a situation that we moved to the right how many decimal places? 2 decimal places. Which implies that for each 0 in this particular equation here that you ignored initially, the decimal point must always be brought back and must be brought back here. For example, when we are, in this particular case, we are multiplying by 10, multiple of 10. So we multiplied by a multiple of 10 up there and a multiple of 10 below, which implies that the moment we did that, we didn't change anything. The value remained the same. We only went for the equivalent number of the same. Multiply this one by 100 and multiply that one by 100. Take note that 100 over 100 is just 1. So we've not changed this. The value of this figure is still the same. That's why now when we divide, it is easier to divide like that. So when dividing, we simply divide, and what we get here is the same because it's supposed to be multiplied by 100 over 100. That's why I'm saying this one is the same as 1 over 1, which is thus the same as the answer that we have. But in a situation where here we were required to divide by 10 or multiple of 10 to get to eliminate our divisor, then it will mean that for each 0 in the question that you ignored, you'll have to move the decimal place to the left so that you can finish it, the assignment. Let us look at the work first. Examples on dividing decimals by whole numbers. Dividing decimals by whole numbers. Question says calculate calculate this. Now, this is a decimal and we are dividing by a whole number. So, just that one, you take it straight as it is. We have 42.837 divided by, we have 3 here. So the division is just straight. We have 4 by 3 is 1, carry 1. We have 12 by 3 gives us 4. Now the decimal point of the question we have, which is the dividend, and the question should be this, just above it, same position, so that one comes there, there's no remainder. We have 8 divided by 3, that gives us 2, carry 2, 2, gives us 6, carry 2, because of 6. 23 divided by 3 gives us 7, and we shall remain with 2. Then 27 divided by 3 gives us a 9. Gives us a 9. Now, in this situation here, we find that our answer was not interfered because it's a whole number. We are treating it like any other place. But the main thing that we need to observe is the position of the decimal point for the quotient and the dividend. So we find that our answer is 14.279. So in that question, you remember that the division was carried out as normal, but we remember the position of the decimal point should be straight above the dividend as you divide. Let us look at the second situation. (0.0234) divided by 4. Again, in this situation, we have 4, a whole number, and the rest we have is simply a decimal. So 0.0. It is 0.0. That is what we have. That's what we have. So as we start our division, we start from the first point. 0 by 4, this is a situation where we don't have, it doesn't go. Okay, 0 doesn't go into 4. So when it doesn't go, we give it a 0. A decimal point follows because that is the next part. Again, 0 into 4, it doesn't go, we put a 0. 2 into 4, it doesn't go, we put a 0. So any point where we have a number that does not go into a divisor, we shall always be putting a 0. So we have 2 here, so 23 into 4 goes 5 times because of 20, and from 5 times remainder 3, then 34 into 4 goes 6, from 34 remainder 34 into 4, it goes 8 times. That is 32, remainder 2. Now, the 2 remaining, we shall bring a 0 because we need to terminate the division. So we have 20 divided by 4 gives us 5. So our answer becomes 0.00585. Now, point to note. When a number does not go, it doesn't go into a divisor, you'll always put a 0 and move to the next column. For you to be able to terminate, towards the termination at the end there, the dividend, we have to use a 0, we bring in a 0 to be able to terminate the dividend so that we have our decimal in place. So what we are trying to say here is that there are 2 points to note. First point is where the number does not go into a divisor, you place a 0. And 2, when we are terminating the division, then we bring in a 0 so that we are able to terminate the division. Now, let us look at dividing decimals by decimals. Dividing decimals by decimals. Calculate calculate 62.316 divided by 0.03. Now, in this case, as we saw earlier, the important steps or the vital steps that we need to follow when dividing decimals and decimals, we say that where we have a divisor as a decimal with several points, we need to reduce it, we need to bring it to be a whole number. So for us to bring this a whole number, it means we shall move to the right twice, 2 steps. That same applies to the dividend also. We move 2 steps to make them equal. So the first thing we need to do, we shall move the decimal point. That's the first one. That is gives us 0.3. It's not a whole number. You move there, it gives us a 3. So the same 2 steps shall move is here like that. Then we shall have now the division as 6231.6 divided by 3. Now, coming to that now, we are dividing a decimal at a whole number. It becomes a bit easier, 6231.6 divided by 3. Now, the division becomes normal. 6 by 3 into 3 is 2. 2 into 3. Now, there we said earlier on, just a few minutes ago, that when a number does not go into a divisor, we put a 0. So 2 cannot go into 3, so we put a 0. We bring in 3, so 23 into 3, it goes 7 times. And what remains there is simply, it remains 2. So 21 divided by 3, we shall get 7. No remainder. We have our decimal point above the one in the dividend. Then 6 into 3, we get 2. So we find our answer to be 2077.2. 2077.2. So what we notice here is this. The divisor was a decimal. We made it a whole number. And to make it a whole number, the decimal point moved to the right twice. The same applied to the dividend. We moved the decimal place twice. That is how we arrived here and carried out the division in a normal way. So let us look at another one, much more detailed. 0. Divided by 0. That's what we have. 0.03152 divided by 0.002. Again, the first thing we are noticing, the divisor is a decimal, so we need to make it a whole number. And the number of steps you move here, if it is to the right, we shall move the same number of steps to the right on the dividend. But if we move to the left again, the same number of steps will also be applied. So let's see. So this one will move 1, 2, and 3. So this one moves 1, 2, and 3. So we have the new figure that 1.52 divided by 2. So this is an ordinary mathematics. So we come and divide that 1.52 divided by 2. 3 into 2 is 1, remainder 1. 11 into 2 is 5, because of the 10, remainder 1. The decimal, before we move to 15, this decimal point, the position must remain the same. So 15 into 2 gives us 7, remainder 1. 12 into 2 gives us 6. So we're finding our answer as 15.76. 15.76. So you notice that in this question here, we moved to the right 3 steps because there were 3 decimal places there. For us to make it a whole, we needed to move 3 steps. Same 3 steps were applied here, and that is how we arrived at that particular answer. So let us look at a situation where now we are dividing decimals by multiples of 10. Remember, when we talk of a multiple of a number, it is the number which that number can divide, divisible by that number. So a multiple of 10, it starts from 10 itself, 20, 30, 40, as long as it can divide 10 without a remainder, we say that's a multiple of 10. So we want to see a situation, how do we handle numbers when dividing by numbers that are multiples of 10. As we saw earlier on, this question will be like as follows. Calculate calculate 67.04 divided by 8,000. 67.04 divided by 8,000. Now, before we start working this, I want us to know this. When we are dividing by a multiple of 10, we look at those zeros. Those zeros are not negligible. We shall go and ignore them, but put in mind that how many zeros do you ignore? That number of zeros are the ones which you are going to dictate the number of decimal places we shall be moving to. So in this particular case, we are going to have our question in a very simple way. We shall first assume, or the zeros, and the zeros are 3, so that we have 67.04 divided by 8. Take note that in this particular case, we have ignored We have ignored 3 zeros. We have ignored 3 zeros. So if that is the case, now the division here is carried out in an ordinary way. That is 67.04 divided by 8. So 6 into 8 is not possible. So when we say that if it cannot go into a number, we put a 0. Then we have 6 remaining. So 67 into 8, it gives us 8 because of 64 carry 3. The decimal point will come in. The decimal point will come in. Then we have 30 into 8. We have 3 because of 24. We remain with 6. And finally, 64 into 8 gives us 8. So we are having 8.38. Now, there are zeros that we ignored, those zeros need to be brought back at this particular time. If at all, you see, we were multiplying, we were dividing here, which means if it's the division, the number of zeros we ignored will move the decimal point to the left by the same. So we ignored 3 zeros in this particular case. Now we take this number and divide by 1,000. 1,000 is equivalent to the 3 zeros we left, so that's for a multiple of 10. So it will be that this decimal point here will move to the left 3 times. 1, 2, and 3. So that we have 0.0838. Now, what you realize there is that at first we ignored the zeros. But the moment we came into our final answers here, we brought in what we had ignored. That is equivalent to 1,000. That is the 3 zeros. And when we divide this, it's the same as moving the decimal point to the left 3 times. And that's how we come to settle on this. So when dividing a number by a multiple of 10, as much as we shall ignore the zeros, but at the end of the answer, we bring them back and divide by the multiple of 10 that we had ignored. Let us look at another question, it's a similar one, and see what we can do. Calculate 236.14 divided by 200. This question is similar to what we've covered, but we want to see how does it behave when we are handling a number divided by a divisor which is a multiple of 10. So as we said here, we shall ignore 2 zeros in this case here, and then we shall have 236 divided by, 236.14 divided by 2. So we have reduced this to be a decimal divided by a whole number, putting in mind that we have some 2 zeros kept aside. So this one becomes 236.14 divided by 2. 2 into 2 is 1. 3 into 2 is 1, carry 1. 16 into 2 is 8. No remainder. Then 1 into 2 is can't go, so we put a 0. Carry 1. 14 into 2 is 7. So we have 118.07. But then we have 2 zeros that we ignored, so we divide by 100. So we are dividing by 100. The number of zeros are 2. That simply means that the decimal point will move to the left 2 steps. So we shall move the first step and the second step here. So the answer becomes 1.1807. 1.1807. So we realize that when we are dividing a number by a multiple of 10, we always ignore the zeros, carry out the division with the whole numbers, and then bring back the 100 towards the end. Now let us look at evaluation of this division using either multiplication or division. But this time round, I want us to consider evaluating using order of operation. Evaluating using order of operation. So calculate using order of operations. And the question is, now the question here is 3.8 minus 1.6 multiplied by 0.45 divided by 0.4. Now, in this question, remember, they are asking us to consider and put more emphasis on the order of operation. So as we approach this question, we need to follow the order of operation. Where the order it would be, wherever we have the brackets, we remove the bracket order of division and multiplication, if any, and then subtraction and addition. In this particular case, bracket is not there. Order of multiplication and division is there. So we first, here, we need to carry out the multiplication and the division, remember, from the left to the right. So the first one to be handled, we shall first handle from the left to the right. We shall first handle this as our first step. The second step is that. So this is the first one, the second one, and then the third one will be everything. So remember, it is from the left to the right. The order of, that's the bracket order of multiplication, division, addition and subtraction. So we first start by looking at that. So we shall be required to multiply the first bracket here. So just to rewrite what we have, it is 3.8 minus 1.6 multiplied by 0.45 divided by 0.4. That is what we have. So as we say the order, we shall tackle this one first. That is 1.6 multiplied by 4.5. You can use your calculator to work out the problem by yourself, or you can do it mentally. So, maintaining the order, here, we shall first work out this. And when you multiply this, you'll find that it will be now 3.8 minus 0.72 divided by 0.4. So we have started from the left and we are handling the multiplication and division. But we haven't handled the division. So the next one that follows is the division part. Take note that for us to get this 72, we needed to multiply this. And the multiplication there is carried out in a very, very simple way of simply multiplying the numbers as if they are whole and then count the number of decimals, and there you'll get the number that you require. So for the division here again, this one is, the divisor is a decimal, so we need to make it a whole number, which means that we shall have to move the decimal point one place to the right, both for the two sides, so that we have 7.2 divided by 4. So if that is the case now, you'll find you'll have 3.8 here, minus, now 7.2 divided by 0.72 divided by 0.4 is the same as, this one here is the same as 7.2 divided by 4. When we move the decimal point to the right once. So then here, 4 into 7, 7 into 4 goes 1, and then we'll carry 3, 32 into 4 goes 8. So we're saying that when we work out this, we'll have 3.8 minus 1.8. So that gives us 2.0 which is just equivalent to 2. Now, what is the secret behind this? The secret behind this is the order, which you call the bracket order of division, multiplication, addition, and subtraction. Here, we did have the brackets here. So we follow the order of division and multiplication, which is here from the left, then followed by addition, which we did have, but we have the subtraction, and that is how we arrive here. If you don't follow the order, you'll always find the different answer. So that is how we approach this. So let us look at other questions in general. I want us to look at a situation where we have a divisor with quite a large number of decimal places. For example, calculate 432.2 divide by 0.0002. Now, our dividend has one decimal place, but our divisor has got good number of decimal places, that is about 4 decimal places. As we said earlier on, whatever happens on the divisor should also happen on the dividend. So in this particular case, the decimal point here needs to move 4 steps to the right. And the same will apply here. So if we do that, if we are to move 4 steps here to get there, then this one here, it will be 4, 3, 2. The first step gives us 2, and then the last 3 steps will bring in the zeros. So these zeros are coming as a result of trying to bring in what happened on the divisor to happen also on the dividend. So we have this number as 4,322,000 divided by 2. So at this point now we just simply take the number and we divide by 2 and it will be done. So this one will give us 4 into 2, it is 2, this is 1 carry 1, 6, 1, then 0 follows. We said when a number does not go into a number, we always put a 0. So we find our answer is 2161000. That is our answer. So what are we trying to say here? If you exhaust from the dividend, if you exhaust the decimal such that you are at the end, it does not mean that you stop there because you have not yet eliminated the decimal point on the divisor. So if you move on the divisor 4 steps, also on the dividend you must move the 4 steps, and that's why this number was reduced to this. Now let us look at some questions which are slightly different that require us to mentally understand and apply what we require. Now find the missing digits in these divisions. Find the missing digits in these divisions. So the number that we have is that. This is just straightforward. They're asking us to fill the boxes. That one can only be filled by simply carrying out the division. Then we look at the principle behind which they used, and you'll find that it was 2 divided by 3. It cannot go into 3, so we put a 0, and then we carry 2. Then we have 26. 26 into 3 will go 8 times. That's because of 24. And we carry 2. So 8 is here. We have filled the first digit. Because of that, it gives us 24 carry 2. 27 into 3, this one goes 9 times without the remainder. So the missing digits here is 8 and 9. And this one can simply be found by simply dividing the number with the divisor. Another one, we are supposed to fill in. We don't have a digit here, but we have a 2. That's what we have. 1.-2 divided by 3 is 0.64. To fill this just normal ordinary way, we go the way we always carry out our divisions. So 1 divided by 3 is not possible. It cannot go into 3. So we put a 0. Having put a 0 here, we have a number that remained here. And this number, what can be done for us to get it? Now, there are two options. One is mentally to try and find it. But because we have the knowledge of decimals, simply take the quotient that we have, multiply by the divisor. It gives you the value of the dividend. So for a bright idea here, it will be now, this one, for us to get what is missing here, we shall take 0.64 multiplied by 3. This is a decimal multiplied by a whole number. So we handle the multiplication just like other numbers, but we count the number of decimal places. So this one is simply going to give us 12 carry 1, and 3 by 6 gives us 18. 18 plus 1 that we carried gives us 19. So decimal places that we have were 2. So the decimal place will come here. So let us see, is it possible? So if this is the case, that means the missing digit here is 9, and we can try to confirm it. So for us to get 9, take note that we have taken this, and this one we call it the quotient. Multiplied by the divisor, we get the dividend. But the dividend was not complete. That's why we multiplied and found that's what we have. So we can now prove and see if 1.92 will give us 0.64. Let's see. 1.92 divided by 3. 1 into 3, it does not go into 3. We put a 0. We carry 1. Then 19 into 3, it goes 6 because of 18. We carry 1. 12 into 3 gives us 4. So we can confirm that we are able to confirm that 1.92 is the digit that was required for us to complete the dividend in the above question. On the division of decimals, sometimes it's not only about figures. We can also have a statement where we shall be required to apply the knowledge of the decimals. From the sentence that we read, we come out with figures and do the definition. Look at the following question. Charlie paid So in this statement question, Charlie paid $12.72 to fill his ride-on lawnmower with 8 liters of fuel. What was the price per liter of fuel that he purchased? So what we are trying to see here is that the $12.72 that Charlie paid is the total amount of money he paid after fueling his ride-on lawnmower of 8 liters. So how much is it per liter? So we find that here we shall take the total cost, which is $12.72, and then the quantity or the capacity of the liter, which is 8 liters. So to find the cost of 1 liter, it will be 12.72 divided by 8. 12.72 divided by 8. This is a decimal divided by a whole number. So we go into it in a normal way, that is 12.72 divided by 8. 1 into 8 is not possible, it does not go into it, so we put a 0. 12 into 8, we get is a 1, and we remain with 4. The decimal point of the dividend should be in the same position as the decimal point in the quotient. So we have now 47 divided by 8. 47 divided by 8. This one will give us 5, which goes into 47, which gives us 40. And 40 will remain with 7 here. Then 72 into 8 gives us 9. So you'll find that now our price per liter this time becomes 1.59, but it is in dollars. So for Charlie, who spent $12.72 to fill his ride-on lawnmower with 8 liters of fuel, he had spent $1.59 per liter. So we find that in most cases, decimals are used in many areas in applications, but we should be able to know the best way to approach it using the various steps that we have gone through. In our next class, we shall be looking at how to compute with the negative fractions. So we shall be in the computation of negative fractions. We have always seen the computation of negative integers. This time we want to look at fraction and see how to approach it. Thank you.